Hello kids! Good day! We are now in quarter 2, week 5 of mathematics, grade 6. And I am still your teacher, Teacher Angel, to help you understand our new topic for this week. By the way, hello and welcome back to everyone. For those who are not still subscribing this channel, please subscribe. And if you like this video, please like. Thank you. First of all, before we discuss, you need to have the following first. Number 1, your module in math. Number 2, your notebook. And number 3, your ball pen. And I request that everyone must follow what I am saying that is located on your module, so that you will understand clearly the examples that I will give you in this topic. Okay, let's proceed. At the end of this lesson, you will understand the exponent and the base in a number expresses in exponential notation. And number 2, you will know the significance of this topic to any mathematical operations. So, our topic for today is very, very important. So, you must listen well. Let us have a quick quiz first. Are you ready? What is 3 times 3 times 3? Three times 3 times 3 equals 27. Who got the answer correctly? Very good. Let's go to number 2. What is 2 times 2 times 2 times 2? Times up. The answer is 16. Did you get the answers correctly? If you did, very good. Now you are ready for our topic today. For today's lesson, we will be discussing about describing and giving the value of numbers expressed in exponential form. Let us first study the following terms. Number 1, exponent is a number that gives the power to which the base is raised. Number 2, base is any value of positive integers but not equal to 0. That raised to 0 is 1. So we will be talking about today about exponent and base, exponential form and expanded form of this number. Okay, to understand it well, let us go to the examples. Example number 1. 4 raised to 2, where 4 is the base and 2 is the exponent. And you can read this example as 4 raised to 2 or 4 raised to the second power or 4 squared. Okay? These terms are all the same. 4 raised to 2, 4 to the second power, or 4 squared. Understand? So those terms are all the same. In this example, 4 is the base, which is in the lower part of this example, and 2 is the exponent, which is always on the higher right corner of the base. Don't be confused. Please see and look carefully. Okay? The exponent will determine on how many times you to multiply a certain number or base to itself. This means that the exponent will be the main factor, or will be the one to determine on how many times you will multiply the base to itself. So as we can see in this example, the base is 4 and the exponent is 2. In other words, you must multiply 4 2 times by itself. Understand? So 4 times 4 equals 16. Did you get it? Let's go to another example. Example number 2. 4 raised to 3, or 4 to the third power, or the other term for this example is 4 cube. But we will be using 4 raised to the third power. What is the base on this example? And what is the exponent? Have your guesses. Let's see if you're correct. Okay, the base for this example is 4 and the exponent is 3. Always remember, the exponent is on the higher right corner of the base, and the base is always lower than the exponent. So this example is called the exponential form because it has its exponent. This is an exponential form. Okay? So let's go to the expanded form of this example. So when we expand this exponential form, it becomes 4 raised to 3 equals 4 times 4 times 4. Because, as we have mentioned earlier, the exponent determined on how many times the base will be multiplied by itself. So in this example, the base must be multiplied by itself 3 times. So as you can see, 4 times 4 times 4, 1, 2, 3. Okay, so 4 times 4 equals 16, and then bring down the another 4. 4 times 16 equals 64. Very good. So let's go to the another example. Example number 3. 2 raised to 5. What is the base on this example and what is the exponent? I know you can do this. Let's see if you're correct. The base in this example is 2 and the exponent is 5. Wow, you're getting used to it. Very good. So, the exponential form 2 raised to 5 will be in its expanded form 2 times 2 times 2 times 2 times 2. Because we need to multiply 2 by itself how many times? 5 times. Let's see if this is 5. 1, let's count. 1, 2, 3, 4, 5. So, this is the expanded form of this exponential form. So, 2 times 2 equals 4. Let's get the value of this. 2 times 2 equals 4. And then bring down times 2. 4 times 4 equals 16. Bring down times 2. And the answer is 32. Did you get it? Very good. Let's go to the last example. 6 raised to 3. What is the base and what is the exponent for this exponential form? Let's do this quickly. So in this example, number 4, the base is number 6 and the exponent is number 3. Now let's get the value for this exponential form. First, we will be doing its expanded form. 6 must be multiplied by itself how many times? 3 times. So 1, 2, 3. 6 times 6 times 6. 6 times 6 equals 36. Bring down 6. So 6 times 36 equals 216. Very good. Now, if we will be doing this in a table form, this will be the result or the look for it. So this is the exponential notation or exponential form of the examples that I have mentioned earlier. This is the expanded form and these are the value. So the first one is 4 raised to the second power or 4 raised to 2. This is the exponential notation. When we transform it to expanded form, it will be 4 times 4 because we must multiply 4 2 times to itself, okay? And when we multiply 4 times 4, it is equals to 16. So the value for 4 to the second power or 4 raised to 2 is 16. Next is 4 to the third power or 4 raised to 3. The expanded form of this exponential notation is 4 times 4 times 4 and its value is 64. Next is 2 raised to 5. So the expanded form of this exponential notation or exponential form is 2 times 2 times 2 times 2 times 2, which results to 32. And the last one is 6 raised to 3 equals 6 times 6 times 6, which is equals to 216. So I hope that you are getting what we are discussing right now. You can do this. Oh, let's go to the hard mode of this topic. Brace yourselves. Let us now do it with positive and negative numbers. As you can see in this example, 5 times 5 equals 25. If a number do not have any negative or positive sign before each number, it is automatically a positive number. So this will be positive 5 times positive 5. So positive times positive equals positive. So 5 times 5 equals 25. Okay? Let's go to the other example. Now, this is both their negative sign before each number. So, as you can see, negative 5 times negative 5 equals, what do you think will be the answer? Is it negative or positive? The answer is positive because a negative number multiplied by a negative number is equals to positive number. So negative times negative equals positive. That is why even though these two numbers are negative, its answer is still positive. So negative 5 times negative 5 equals 25. Do you understand? Let's go to the other example. Negative 5 times 5 equals, what do you think will be the answer? The answer is negative 25. So a negative number multiplied by a positive number is equals to a negative number. Okay? So negative times positive equals negative. So negative 5 times 5 equals negative 25. So to summarize what I have discussed earlier, remember that a positive number multiplied with positive equals positive. So that's why this is 5 times 5 equals 25. And then a negative number multiplied by a negative number equals positive. So negative times negative equals positive. And then a negative number multiplied by a positive number equals negative. That's why negative times positive equals negative. If they have the same sign like this, positive and positive, it is positive. This one, negative and negative equals positive, even though their signs are both negative. Okay? But because they are the same, negative and negative, it is equals to positive. Unlike this one, they are not the same. This is negative and this is positive. So the answer will be negative. Do you understand? This is very important because we will be using negative numbers in our next example. So if you understand this well, this example well, these examples very well, you will be it will be very easy for you to understand uh, the exponential forms in positive and negative numbers. Okay? So let's move on. So the example here is negative 10 raised to 2. First, we must know what is the base and then what is the exponent in this exponential notation or exponential form. So the base here is negative 10, which is here, and the exponent here is 2, which is in the upper right corner of the base. Okay, so let us expand this exponential form. So negative 10 times negative 10, as we have discussed earlier, negative times negative equals positive. So the answer is 100. Now, let us go to the last example. Example number 2. Negative 2 raised to 5. What is the base in this example? And what is the exponent? I know you already know this. Yes, correct. The base is negative 2 and the exponent is 5. So this means that we must multiply negative 2 to itself 5 times. So let us expand this exponential notation. The expanded form for this exponential notation is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. If we count this, 1, 2, 3, 4, 5. So this is correct because the exponent is 5. But take note that we are carefully looking for the sign in these numbers. Do not forget the negative sign of the base, okay? So to simplify this, negative 2 times negative 2 equals positive 4. Remember, negative times negative equals positive, as well as negative 2 times negative 2. This is equals to 4. And then we will bring down negative 2. Now, 4 times 4 equals 16. Bring down negative 2. 16 times negative 2 equals negative 32 because a positive number multiplied by a negative number, it is equals to negative number. So 16, which is positive, times negative 2 equals negative 32. So be careful if the base is a negative number, because if you will be um, uh, calculating this in a wrong way, example, you made this 4 as negative, your answer will not be negative 32. It will be positive 32, and it will be a wrong answer, okay? Because a positive number can never be a negative number. They are different from each other even though they are both 32, okay? So be careful. Congratulations, kids! We are done for this topic, and I know that at this chapter you can already describe and give the value of numbers expressed in exponential form. I am so proud of you, and keep up your good work. See you next week for our new lesson. God bless and goodbye.